Hello guys, welcome to Lead Electrical Academy. Today we will see the single phase fully controlled converter DC series excited motor. So in the previous class we have discussed the single phase semi controlled converter fed DC series excited motor. So in this class we will discuss the single phase fully controlled converter with the DC series excited motor. So for this, as you know, fully controlled converter means there are 4 thyristors will operate, T1, T2, T3 and T4. These 4 thyristors will be operated. So it is connected to a field resistance. RA plus RF is the armature resistance and field resistance will be there, and which is connected in series with the armature inductance, and which is connected to motor. Motor will have a back EMF. So here EB is known as back EMF, and RA is known as armature resistance, and RF is the field resistance, and LA is known as armature inductance, This is the circuit. So there are 4 thyristors, T1, T2 and T3 and T4 will operate. Source voltage will be VA. This VA is known as source voltage, and the IA is known as source current. IA is the source current, and the load current will be I0. I0 is known as load current, and V0 is the load voltage. So this is the circuit explanation. Next we will move on to waveforms. So for these waveforms, as you know, VA is known as the source voltage. Source voltage will changes for every half cycle, positive and negative. For 180 degrees it will be changes. So pi, 2 pi and 3 pi and 4 pi it will be changes. So for positive and negative half cycles. And next we will move on to the load voltage. Load voltage will have 3 parts. So we will discuss one by one from alpha to pi. So if you see from alpha to pi, the thyristors T1 and T2 will conduct. And it will conduct up to pi plus alpha. So we will consider this as alpha to pi plus alpha. T1 and T2 will conduct. So alpha to pi plus alpha will take as T1, T2 will be in turn on condition. So the current will be continuous, no? So it can be represented like this. So from alpha to pi plus alpha, the current also continuous. Next we will see the from pi plus alpha. From pi plus alpha to 2 pi plus alpha. From pi plus alpha to 2 pi plus alpha, if you observe, these T3 and T4 will turn on. T3 and T4 will turn on. So I can write here T3 and T4 will turn on, and T1 and T2 gets off. Next, for next 2 pi plus alpha to 3 pi, again T1 and T2 will conduct. Again T3 and T4 for 3 pi plus alpha. So this cycle will repeats for continuous conduction, and the current will be continuous for both the thyristors. If T1 and T2 are turned on, or T3 and T4 will be turned on, the current will be continuous waveform. This is about the voltage and current waveforms for fully controlled converter for DC series excited motor. Next we will move on to the equations. So if I see the equations, this if I apply KVL in the loop equation, so I will show the circuit. So this is the circuit. For this circuit, if I apply KVL, Kirchhoff's voltage law, the algebraic sum of voltages around a closed loop is 0. So VA equal to IA into RA plus RF is the current flowing through the resistance, and voltage across inductor. Voltage across inductor will be LA into DIA by dt plus back EMF. So I can represent this in the here. VA equal to IA into RA plus LA into DIA by dt plus back EMF. This is the voltage equations. So from these voltage equations, if I take the average motor terminal voltage will be taken for a half cycle. So VA equal to 1 by pi and it will conduct from alpha to pi plus alpha, no? So alpha to pi plus alpha, Vm sin omega t d omega t, Vm sin omega t d omega t. So if I take these boundary constants and apply integration, so the value will be V naught equal to 1 by pi, and if I apply integration of sin omega t value will be minus cos omega t and alpha to pi plus alpha. So if I take this value, the V naught value will be 2 Vm by pi cos alpha, 2 Vm by pi cos alpha. This is the average motor terminal voltage. So I can substitute in the KVL loop. As you know, KVL in the loop, if we apply, Ia into Ra is the armature resistance, and Kf into Ia into speed plus K resultant, this is the constants. So we have got this value, 2 Vm by pi cos alpha, or I can also write as 2 into root 2 into Va by pi cos alpha. I can write both the terms, as we know Vm equal to root 2 into Va, Vm equal to root 2 into Va. So I can substitute here in the place of Vm, 2 into root 2 into Va by pi cos alpha. So as you know, speed equal to Va minus Ia Ra by Kf into Ia plus K resultant. This is the speed equation. So I can substitute this Va value. Va value we have calculated, 2 root 2 Va by pi cos alpha. So if I substitute here this value, this is the speed equation. And the torque equation, as you know, for series excited motor, torque is directly proportional to Ia square, torque equal to Kaf into Ia square, So if I take this Ia value equal to 2 root 2 Vs cos alpha by pi by Ra plus Kf into speed minus K resultant into speed. This is the Ia value. For this Ia value, if I substitute here, Kf torque equal to Kf into Ia square. This is the Ia square. So whole the term will be Ia value. So we have calculated the torque value, speed value, as well as torque equations. This is about the series excited motor fully controlled converter. Okay, we will meet in next class. Thank you guys.